We're going to show a couple of things in GDB that I've found over the years. So we deal a lot with, so we make this tool called UndoDB, which is, well, the most common interface to it probably is GDB. So a lot of our customers spend their time in GDB, and we work with them, and sometimes, often, it's more they're looking at how to do something in GDB, and I've kind of picked up some good stuff over the years that I thought it might be interesting to share. So I just want to start by saying, so I would be the first person to admit that GDB is not intuitive, right? But it is very powerful, and I think there's an important distinction to make between ease of use and ease of learning. And it's not easy to learn, but it is easy to use when you get to learn it. And it's not that hard to learn, right? Sometimes you just need to know that these things exist. So, here's a pretty simple program, not much more than hello world, but it's got a few lines, so I can at least type next a few times. And I compile just as normal, and I run this in GDB, right? And many of us would have done this at some point. And you can start, which just saves you typing break at main and then run. And it's okay, I'm at line 6 of my program, but I don't have any context, right? And well, I can get a list, so that's kind of okay. But what I want to show you is probably the thing that I think is probably least known and most useful, like the thing that scores best on both ranks, which is this thing called TUI mode, which stands for Text User Interface. And it's a really bad name, because surely that is a text user interface, right? And it's a bit, well, 1970s, and it's just kind of clunky. But if you type, and I don't know why you have to type this and why it's so obscure, but if you type Control-XA, then you get the real TUI, text user interface, which is like screaming into the 1980s, but it is still pretty useful, right? So now when I type next, I get much more context of what my program is doing, right? It's not perfect, right? Like all Curses programs, it sometimes goes a bit weird sometimes. So if I type next again, my program's printed out hello world, and it's kind of screwed up my display, and that's a reliable way to make it go wrong. There are more interesting ways it goes wrong, but none of them I could find that were reliable. But if it does, you can just do Control-L, and it repaints the screen for you, so it's quite handy. And you can actually do a bit more. So you can, if I go Control-X2, I may not have enough characters for this, but no, let me make this slightly smaller so that I was all perfectly set up for this before my system reset. So where were we? So we're here. Okay, so, and then you've got Control-X2, I get multiple windows. And so here, obviously, I've got my source code with my assembly. And if I go Control-X2 again, it will cycle through, and then I can get my registers as well. And you can change what you're seeing. So I can go TUI reg. That's the general purpose registers, but if I go TUI reg float, and it will show me the floating registers. So you can sort of set things up so it just makes it much more convenient. You don't have to spend all that time looking through and flipping back and forth. I'm going to Control-X1, I'll go back. And let's go Control-X1, and we go back to our source code. And the other thing you'll find that you can do in this mode is if I'm doing up arrow here, and it goes up and down, which actually is really annoying, because what certainly I do a lot of the time is you go up arrow in order to get the previous command, right? And now you can't do that anymore. But turns out, and I only found this out really recently, you can go Control-P, and then I can get my previous command. So Control-P and N in TUI mode goes up and down my command history. I think you can do Control-P and N normally in CLI mode, but certainly I would just normally use up and down there.
Question.
Yeah.
And do you know why that's that? Because you're a Vim user. No, really. These are all Emacs bindings. These are all Emacs bindings.
Yeah, so you should just be able to press J and K and then it would be all right. Yeah? I mean, I don't know. I don't know what's wrong with the world. But so there you go. So that's TUI. How long do we have? We're kind of racing through now. The other thing, I think, that's the second probably most useful thing that I think a lot of people know about now, but still not everybody, is there's a Python interpreter built into the GDB. Anything since version 7. And so this is very, very powerful, right? So I can do, just type Python, and then, I don't know, so you can do print hello world. Oh, at least if I could type. And the Python works, all right? Now, if I go, I'm going to come out of TUI because it's sometimes a bit clearer. So I can type multiple lines of Python, and you can do, it's pretty much a full Python interpreter, at least as long as your GDB build isn't messed up, which sometimes we encounter quite a lot, actually. But import OS, and then I can print, I don't know, my PID is get PID. Right? So you can do, anything that you want to do in Python, and actually you can define functions that you can then call from the command line, and you can even define functions that then you can become sort of first-class GDB commands, which is kind of cool. And it's not just that there's this Python interpreter sort of sitting there that you can just do stuff. It's really tightly bound to GDB itself. So, for example, let's put a couple of breakpoints in. So, switch back to there. So if I break at main, and I don't know, I'll break at line 9 as well. So if in Python, I can go, let's print gdb.breakpoints, and that gives me a list of these breakpoint objects, right? And they contain all the kind of things that you'd want. So I could do breakpoints, take the 0th one, and let's show the location. Okay, and so you can find out information about those breakpoints, and you get all the normal things enabled, whether they're enabled, and there's advanced things set. And you can even set breakpoints from the Python. So you can go, let's try and get this right. If I just need to create a breakpoint object, and I give it a location specifier, so let's put one on line 7. And, oops. And now that breakpoint's appeared, right? And you can see the breakpoints on the left here. So by using these kind of things, and you can find out information about what the source file is, and you can look up all your local variables. And one of the very cool things you can do that I don't have time to show now is that you can do Python pretty printers. Right, so if you've got these structures that you've made, and when you type print my structure, you want it to look nice, you can do that in whatever way that you want. Another really, I think, quite useful thing is, well, I'm a bit biased here, but reversible debugging. Now, GDB has inbuilt reversible debugging, so you don't need to be a customer of ours to take advantage of this. Our stuff is much quicker and generally much more awesome, but still you have reversible debugging in GDB that works quite well. So here I have a program that is just, it's a bubble sort, right? Very simple. It doesn't really do anything. It just fills an array with randomized data, and then it sorts it. So it doesn't even print anything out. But I happen to know that there's a bug in there that doesn't quite go every time. So if I run that in a loop, it usually works. And well, this is the peril of intermittent bugs when you're waiting for them. But there we go, right? Every so often, it segvies. And okay, it's made a core dump, so that's useful. So there it is. So I can load that up. So let's have a look. That's what we usually do with a core dump. But we've got no stack information at all. So clearly this is some kind of stack smashing bug, and the core file's of no use. So what I'm going to do instead I mean, that runs no good now. That information is all gone. But if instead I start GDB like this, and I'm going to, actually, I'm going to put what I want to do is enable reversible debugging so that when it faults, I can step back a bit, and then I can get the context, right? I don't need the backtrace. But I need to run it a bunch of times as well, and obviously it's kind of tedious to do that by hand. But you can set breakpoints, and you can have commands that issue when those breakpoints are hit. So if I set a breakpoint on main, and I set another breakpoint on, I happen to know, this is a bit of a hack, but I happen to know that there's this, when it exits, normally it goes through this line. Actually, I probably could just do it on the last line of main. Anyway, that'll do. And I'm going to apply commands to run when these breakpoints are hit. So when breakpoint 3 is hit, I just want to rerun. And when breakpoint 2 is hit, which is the one at main, sorry, command 2, I want to enable recording and continue. And now, oh, hang on, before I do that, I want to set pagination off, because that will get annoying. And now, when I rerun, what it's doing is every time it hits the top breakpoint at main, it's going to turn on recording and run through, and then when it gets to the end, it's going to just start again, right? And once again, we have this kind of indeterminate wait, because this is an intermittent bug, but if we're patient enough, eventually, it doesn't get to the end. It's stopped in hyperspace, and I can start to look around at what's going on. So I can look at my program counter. Okay, so I'm there. If I do X to look at the memory there, we can't access that memory. I appeared to have jumped into hyperspace. As we saw before, backtrace is kind of garbage. But I can reverse step I, which is like step I, but just going to go back one instruction. And suddenly, ta-da, we're back in sensible land. Now I have a stack that works. And you can look here, I'm at the end. So what's going on? Well, I can look at the disassembly of the code, and I can see this little arrow at the bottom tells me that I'm trying to issue a return instruction. So not that surprising as we think we got some kind of stack corruption. Well, let's have a look what's going on there. So if I look at the stack pointer, the stack pointer is that. So return on x86 at least will return to the top of the stack. And if I look at the top of the stack, sure enough, that is the bogus address that we were jumping to. So someone's clearly written rubbish onto the top of my stack. So how do I know what that is? Well, if I watch that, right, watch point, so sometimes called a data breakpoint, and the idea is you set these watch points, and usually what you do is you run forwards until the data is changed. What this is going to do is run backwards until that location in memory changes, which is going to be who's written to my stack, which ought to have been when I entered the function, but we suspect from what we've seen is not. And I'm going to reverse continue. And so now I've gone back in time to when that stack was modified, and perhaps slightly unsurprisingly, it's when I'm writing into my array. Let's have a look. What's I at that time? So I have full data at this point, and I can see I is 35, and if I do my very annoying up arrow, we'll see that the array is only 32 elements long, and of course the bug is that we've got this, we're using % size of array when we should have used, that's the number of bytes in the array, not the number of elements. So there was 3 very quick things. There's loads and loads of other stuff. I've just ignored my slides, but there's loads of cool stuff. I'm going to do a longer open content session tomorrow. Well, I still won't have time to go into all of this, but I'll go into more of it, and some other cool stuff as well. So thank you for your attention.